Now let's go ahead and take a look at some practical examples of Git and how we're going to be using it throughout this class. The first thing we're going to check out is basically how we would go about creating a repository from scratch, right? Let's say there's this new project we want to start up. We don't have it sitting on a server anywhere yet, and we're just going to kickstart it as we go. So the first thing we're going to do is we're just going to make a folder for that project. And we're just going to call it my awesome project. So we're going to go ahead and go into that folder, which apparently I can't type correctly, right? And we're going to notice the folder's empty, project's empty, just as we expect it to be. So the first thing we want to do is create a Git repository here. So we're just going to do git init, right? We now have this empty Git repository. And again, there's nothing here unless you go ahead and try to show your hidden files, and that's when you will go ahead and see that hidden.git folder. Now again, you're never going to want to go in here. There's almost no reason you ever would need to. So it's just good enough to know that that folder exists now that the repository has been created. All right, so if we go ahead and do git status now just to see what's going on, we can basically see there's nothing to commit, no new files, no anything. So let's go ahead and make our first file. So we're just going to call this hello.c. We'll just make a simple hello world program. Studio.h, main, blah, blah, blah. And then we'll close it, and we'll just make sure it compiles quick. Run it, cool, it printed, we know we're good to go. And I'm just going to remove the a.out quick. Okay, so now if we do git status, we can basically see Git is now telling us that there is a new file in the directory that the repository doesn't know anything about, right? It's an untracked file, and it's called hello.c. And it's also helping us out and saying if we do want to track this file in the repository, go ahead and use the git add command. So if we do that, because we do want to track this file, we're going to do git add hello.c. And now if we do git status again, you can basically look at that staging area that I was talking about before, right? Which is now, this is saying when we commit or when we run the commit command, we will add this file in its current state to the repository, which is exactly what we wanted. Now the counter to this is, let's say we accidentally added a file to our staging area and we don't want that file to be committed. Is there anything we can do? Which luckily, yes, again there is, and Git's giving us a couple helpful messages here to let us know. And in order to do that, we would just run the git rm -- cached file, right? So it would be git rm -- cached hello.c to remove the file from the staging area. Nothing too crazy or complex about that, but it's the exact same process you would do if you had 4 or 5 files in here and you actually only wanted to commit some of them, right? So our file's added to the staging area. Let's go ahead and commit it. So we're going to do git commit, and we're going to do -m because we want to add a commit message. If you don't add the -m file or -m flag, you're going to get dropped into a text editor saying, here, please add a commit message, otherwise it won't let you commit at all. So we're going to say adding hello.c as first file in project. And now we do commit, and boom, our file has been added to version tracking. So if we do git status again, you can see there's nothing to commit. We haven't modified any files. Now, let's go ahead and do some more stuff in our hello world.c file. And we're going to do printf. Let's say that one more time, because why not? So if we do that, we've modified the file. And now if we do git status again, you can basically see it has picked up the fact that we have modified hello.c. Right? And this is the big important thing about Git, is that it can see when files have been changed, and it's going to know exactly what changed in that file. So if we wanted to see what changed, we can actually do git diff hello.c. And this is going to show us the differences between the file that we have currently and the last committed version of that file. Right? So this is basically telling us, hey, we added this new line, right? We're saying plus this line. If for some reason, let's go this, let's delete that line, and then we're going to do printf. This is another way to say hello. And we go ahead and save that. And we do git diff again. Now we can see that, oh, we deleted a line from the file. And then we went ahead and added a new blank line, and then we added our new message. Right? So this is Git that's tracking the changes to the file for us. Now these diffs that you're seeing here become extremely useful when you're trying to make modifications to a file to add a new feature. So let's say you needed to implement a new messaging feature for your application, and you went into your file and made a whole bunch of changes, and you were working on it for some amount of time, but you ended up kind of forgetting all of the changes that you might have made. Luckily, you could use a tool like this diffing feature, which will actually show you all of the changes that you made. Right? So you can go through and you can then review your code to make sure that these are the changes that you actually want to be making. Right? So that's the big important thing. So now we can go ahead and do git add hello.c. So that again adds our file to the staging area, which is exactly what we wanted. Let's say we wanted to add another file. Right, I'm going to do vi file 2.c. If that includes studio.h and main printf. This is the second file. And close that. Right, we can now go ahead and do git add file 2. And if we do git status, now we can see that we have one new file that we're going to add to the repository, and then we have the file that we had modified previously. So now when I go ahead and do git commit, it's going to work with both of these files, adding them both to the repository, which is exactly what I want. If these two files were both implementing some feature, then I would definitely want them added into the same commit so that if my feature broke something, I could revert back cleanly and make sure all of the files that got changed are in one clean commit. So git commit one more time, -m. Actually, I'll show you what happens if you just do git commit, right? It dropped me into Nano, and it's basically asking me, hey, you need to add a commit message here, otherwise we're just not going to do anything for you. So I'm going to type adding new files to complete my awesome feature. And then I'm going to do Control X to save it, which I think, right? Sure. No. Yes. There we go. Right, so now our file has been committed. Now, let's say you were working at a repository and you wanted to see what the history of the repository was. What files have been added, when were they added, what files have been changed, etc. Now you can do git log. And this is basically going to show us all of the changes that have been made to the repository, and it's also going to show us all of the messages associated with those changes, right? So we can see where I added hello.c and then where I finished off my awesome new feature. This is why the commit messages are important, right? Because these are the things that show up when people are going through the logs and seeing how your project has evolved over time, right? So it's very important to put descriptive messages into your Git logs, right? So this is what you would do if you were starting a repository from scratch, and then eventually you could take this repository and push it up to something like GitHub or GitLab or some other central service. But now, let's say there's a project on GitHub that you really want to clone and work on because it's got some really cool features, some really awesome stuff going on. Luckily, we have full support for that already. So let's say you found your project and you're on GitHub, as you can kind of see here. If you want to create a working copy that you can work on and push code back up to, right, you're going to click on this clone link, and then you're going to copy this link right here. Right, you're going to see this clone with SSH or use HTTPS. These are basically just asking you how you want to authenticate with the web service. If you have added SSH keys into GitHub, then you can use clone with SSH. If you would instead want to sign in with a username and password that your client will ask you for when you're trying to clone or push or pull, then you would use HTTPS. But usually once you add an SSH key, then you can use the clone with SSH, and it's just faster because it's not going to ask you for a password. The important thing here is if you are planning on committing code back to this repository, do not use the download zip button. This does not give you the full repository. It gives you the source files, but not the ability to work with the Git commands. You won't have any of the history, and you won't be able to push code back. All right, so we're going to go ahead and copy that link, and then what we're going to do, what's up here, is do git clone, and remember the clone command reaches out to some server and pulls down the repository. So we're going to do git clone, the link that I got from the website, and then I'm going to hit enter. Whoa, permission denied. Maybe I don't have my key in here. Well, let's just use HTTPS for the fun of it. We'll do this one more time. Git clone. There we go. Now it cloned it. So now we can go into tester, which is the repository that I had created before. Do git log. You can see we just have an initial commit because there really are no files in here, right, other than this README file. So now let's go ahead and create our new file. First file.c. Do our standard hello world, because why not? And now we can go ahead and do the same thing we were doing before. We can do git add first file, then we can do git commit -m first file to the project. Okay, and now we are at the exact same point that we were just at in the last example. Now the big question is, how do we get my changes that I've made here, right? I've logged a new change, added a new file. How do I get those changes to be reflected up here, right? Because as far as GitHub's concerned, it still only sees the first thing. To do that, this is where the git push command comes into play. When I do git push, it will send my changes from my repository up to the central server, which in this case is, GitHub. So let's go ahead and do git push. It's going to take a second and do some processing. And now if I come over here and refresh my page, you can see that we have a new commit and my new file showed up. All right, so if we do hit the git commit tab, we can see, well, adding the first file to the project, and you can see the contents of that file that I added. So if I go here, you can also see my other new file has showed up as well. right? So this is basically how you would interact with some remote server. If you're on a team and you're expecting someone else to be updating this code as well, then you would go ahead and just do git pull, which would try to bring in any changes that might have been made that you would not know about. Like, let's just go ahead and make a new file made from GUI.c. And this is just going to really do nothing, right? So we're just going to go ahead and edit a new random file. So we commit this new file. All right, so now you can see we have 3 files here, but we only have 2 in our local. Now if we do git pull, you can see we went ahead and pulled down a new file. And now if we ls here, you can see made from GUI is on our local machine. All right, so this is the basic process that you're going to use to interact with Git repos for the class or just out there in the wild as well. If you have any questions, please don't hesitate to reach out.